Hey guys, I wasn't sure how to edit the next installment, so I figured I would just talk to you directly. I've gone back and forth on this set a bunch of times. I've tried out a bunch of theories, did a bunch of testing. Now I'm reviewing the footage from it, and I realized I've been looking at that test pattern for too long and spending too many hours working on this, especially when I was tired, that I was wrong a few times. By that I mean there were times when I thought the distortion was gone, but on closer inspection it was still there. There were times when I thought the distortion didn't get any better, but it actually did. So I was torn about whether or not to toss all that footage, which is probably several hours of me going back and forth and contradicting myself and trying different things over and over again, or redoing some of those experiments, or just scrapping all of it. I think what I will do is include some of it, but I just wanted you to know that I misspoke a few times. One thing, so upon closer inspection, removing the CRT from the chassis, which I do at one point, and I fold it over. I leave it connected at the socket and remove it physically and get it as far away as I can while still having it wired in. It did reduce the vertical distortion and perhaps the horizontal a little bit, but it didn't eliminate it. Similarly, at one point I just pointed the picture tube straight up and I commented I believe that the vertical distortion diminished, and yes, it did. Likewise, I ran the tuner off a separate 6-volt DC power supply, a couple batteries, and I removed that little transformer entirely, and it did improve it, the vertical and perhaps the horizontal a little bit. What I can conclude from all of this, I'm pretty certain now that most, if not all, of the vertical stretching and compressing, which is what bugs me the most when I try to watch programming, is from that little tuner filament transformer. And that is the one big difference between this set and the Teletone I've referenced a number of times. Yes, there are differences between the Teletone and this. There are subtle ones throughout the design, which also makes me think that the Teletone is more common, and perhaps it came after this set. And perhaps they went back to the drawing board and fixed up a lot of flaws that exist in the Meck. And because the Teletone does not use a filament transformer. They take the 3 tubes in the tuner and add it to the series string going throughout the set. Now as for the horizontal, I'm pretty sure that that is from the hum that we're seeing getting into the video and then the sync separator. Because that makes sense, because that does change the timing of the synchronization pulse every time that scan line goes back and forth, which would absolutely result in the wavering back and forth. And it also would explain why nothing I tried to shield anything improved that situation, because it's not magnetic, it's electrical, it's in the synchronization pulse going throughout the wiring. Whereas the vertical distortion, I think, is caused by magnetic interference from that transformer. I did try putting a shield over the CRT. In fact, yeah, it's still on there. However, I'm not sure what kind of metal that is. It needs to be a specific type of metal called mu metal, which they use in oscilloscopes commonly to provide magnetic shielding. It might only provide electrical shielding. Dogs! Let's regroup a little bit. In addition to this video series, I've also been posting on the Vintage Tech Forum Video Karma, and I've been posting still photos in the community area of my YouTube channel, and there's been a large flow of ideas back and forth, which is great. So let's pull back a little bit. Earlier on, there were a couple issues. One was a loud hum buzz out of the speaker, which was resolved by redesigning the audio circuitry, the first audio amp, to make it, to lower the input impedance of it. The other issue has been distortion on the image on the CRT face. Perhaps the two are related. Yeah, the design of that audio circuit is high impedance. It is susceptible to noise. However, maybe we have an excess of noise. Something is radiating far more 60 hertz than it should be, and that's affecting both. So maybe we should think about that a little bit more. What could be radiating 60 hertz? So electrostatic CRT, there are deflection plates around about here. Two horizontal, two vertical, and they push the electron beam up and down and left and right to paint the electrons across the face of the CRT. Those electrons can be deflected in two ways: electric field, magnetic field. The CRT, as the circuit is designed, is deflecting them electrically. There are sawtooth waveforms on the vertical and the horizontal plates that are several hundred volts, as it takes a bit of voltage, strong electrostatic field, to deflect those electrons, which are being accelerated to the front at somewhere around 5,000 volts. Now, this coating on the inside of the CRT, that is going to that high voltage. There's 5,000 volts on this or so. It's like a graphite coating. It's conductive. That does a pretty good job of also shielding electric fields. And also all the things around here, like this coil that might generate an electric field, they're pretty well shielded. Most of the circuitry is underneath this chassis, which is grounded. Now, I should mention that there is a big cutout around the CRT, and it's not a depressed steel plate. They just cut it out. So there is no shielding underneath that CRT. Okay, so I don't think it's electrical in nature. I think it's magnetic in nature. Now, a number of you have mentioned, hey, the speaker, it's right here. We got wires draped across. Yeah, if you look at the original service info, the speaker is mounted here. However, the mounting holes don't line up. The markings, or the discoloration of the metal, makes me think that it's always been on this side. Also, it's a permanent magnet speaker. If it was a field coil speaker, meaning it's an electromagnet, and there were wires running across, yeah, I could see that definitely having an impact. But also keep in mind, up until very recently, I have had the speaker over on that side. I just recently remounted it over here. But we can move these wires around. We can see what effect that has. There's also this shielded box that generates the high voltage. I did put all the screws back in and the nuts down below, but I can double check that. And that's a curious thing too, how that is powered. I'll talk about that more in a moment. And then there's this, which is a filament transformer just for these three tubes. Now this transformer is a little bit odd that it's completely encased in metal. And it's screwed to the chassis, meaning this should all be grounded. However, several of you have mentioned that, well, it is an obvious source of 60 hertz magnetic field. It's right by the CRT. Let's try rotating it. If you recall, when I did some earlier electrostatic Admiral sets, the early revision had a big old power transformer mounted this way, and then later on, they rotated it 45 degrees. So it looked kind of odd with the power transformer being at an angle, but that is to redirect the magnetic field so that they have less of an effect on the picture tube. I do have some spare shields that I've salvaged from other sets, the magnetic mu metal type shield. I could put one on here. However, some of you have said, a number of you have said, hey, that's just the charm of vintage TV, let it go, move on. I could. I'm not going to be sitting watching a feature-length movie on this TV. It's just going to be for demonstration purposes, I imagine. However, if we just let it go, we haven't learned anything. And that's what I'm hoping to get out of this, is to increase all of our knowledge, our troubleshooting abilities. Let's understand the nature of this problem, and then we can decide whether or not we want to fix it or how to fix it. And we've got a great opportunity here. We can play around with this. It's very open and easy to move things around. So first off, we're using this CRT, which is flipped over and it's as far away from the chassis as I can get it. And that seemed to eliminate the vertical. distortion, which is by far, to me, trying to watch it, the most annoying, because it's like a bubble kind of rising through the image, and it's distorting everything as it goes past. A little bit of side-to-side motion, it's annoying, but not the end of the world. But when things are getting stretched as they move up like a person, I mean, it's very obvious when it goes through their face, because suddenly, like, the length of their nose changes and their eyes and stuff. It's really annoying. And since we know if we put this over here, it goes away, that it is something radiating. There's no question about that. The horizontal seems to be the same, though. So that's got to be some noise getting into the horizontal. And then there's two possible sources I've been seeing of that. There's some ripple on the 300 volt supply, and that's what powers the vertical deflection amps. However, I added additional capacitance that lowered the ripple from about 12 volts peak to peak to 2 or 3 volts peak to peak. I didn't notice any change on the face of the CRT. I then probed the sync circuits, which feed both the horizontal and vertical, and there is most definitely ripple in the sync signals going to the deflection amps. So these are the two oscillators. That's the vertical, that's the horizontal. They're multi-vibrators. There are no coils in this. It's just resistors and capacitors. The sync pulses feed into these two. These are the output amps. And there's nothing obvious around here that would radiate other than this box, which is all grounded and sealed and buttoned up. And then, well, that's it. Leakage on the tubes seemed to be the most likely thing to me. Heater cathode. Series strong sets. The heaters have AC on them. If it leaks into the cathode, it can leak all through all kinds of circuits. I have checked all the tubes repeatedly on several different testers, including one that's very sensitive. Is it possible there could still be some leakage? I suppose so. One thing I can do is just blow through and replace all these tubes with other tubes. I have already done that with all the 12SN7s, the 25L6, the 6AT6, in other words, all these tubes. I've also tried swapping out the two rectifier tubes. Tubes I have not tried swapping out completely are all these, all the 6AU6s, 6AL5s, and the tuner tubes. So we have a few things we can try. First, we're going to undo one of these screws and rotate this 45 degrees, see what it does. Also, I pulled out a magnet, so we can play around with that, and I'll show you what effect a magnet has on the CRT. I will grab a spare shield to toss onto this, just to see what effect that has. Because what I want to know is all the distortion coming from radiated interference, or is it on these signals going into the CRT? If it's purely stuff radiating into the CRT, then we can look at certain solutions for that. If it's problems with the signals going into the CRT, then we know we've got some trouble with some circuitry under here, with stuff leaking into the circuit where it shouldn't be. All of this is made a tad more difficult because none of the service info I found on this chassis shows any waveforms whatsoever. So I just have to kind of guess, does it look right, does it not? For example, so there is some 60 hertz hum in the sync signal going to the horizontal multi-vibrator. It's really easy to see. What effect does that have? I'm not sure. My thinking is that it changes the point at which the oscillator starts. Which means, say it starts a little bit earlier at some points than others, as it's doing those scan lines, it's going to mean that left edge will get a little distorted because the beam will be starting at a slightly different point in time, depending on where that noise is. I think that's what's causing the horizontal distortion. How could we fix that? I've looked around that area. It is near the filter choke. I should say there's also a filter choke down here, which is another obvious source of 60 hertz noise radiating. The sync separator or amp tube is right here. It's physically a couple inches from that filter choke. We could try shielding the filter choke. I have tried swapping this tube out with a couple others and made no difference. Some of you also seem to notice, and I kind of agree, that when there's the band kind of moving through the image, it's not just distorting it by shifting it a little bit horizontally and stretching it a little bit vertically. The brightness seems to change a little bit, which means it might be getting into the video signal. So we need to look at that as well. So there's a lot of stuff to poke around with. But right now, let's just power this up and play around with moving the CRT a little bit and rotating that transformer. Alright, here it is up and running with that CRT removed from the chassis. This is the original picture tube that came with the set. And if we look close, there is far less distortion on it now. There's a little bit of horizontal distortion slowly working its way through the image, and there's a little tiny bit, I think, of vertical issue too. Now if it looked like this while it was in the chassis, I would be inclined to let it go. Now let's take that refrigerator magnet and put it around the CRT. Wow, that is having very little effect. I've got it right around the neck of the CRT now. Huh. Well, I've got a much stronger one in the form of a small speaker. And oh yeah, that definitely has an effect. But that's a really strong magnetic field. There's nothing this strong near the set, well, except the speaker. Alright, well, I'll try rotating that filament transformer. Well, you know what? The distortion is so minor when I've got the CRT out of the set. I think we really need to experiment while it's mounted to the chassis. I think it's going to be too hard to notice. Like if I rotate that transformer now, I don't think we're going to, I mean, I'll try it, but I just don't think we're going to notice any difference. Alright, filament transformer is unmounted, and now I am moving it around. It does not seem to be having any effect. Alright, let's switch to using the CRT that's mounted on the chassis. Okay, back to the twerking. There's something else curious. Listen real close. There's two hums present. One is my PR57, but the other one's out of the speaker. However, it's not really varying with the volume control. But listen close. The hum goes down when I pick up the chassis. Not just when I touch it, when I twist it a little. Oh, that is from the filament transformer on the tuner. I disconnected the two screws. So if I pick it up, the hum goes away. If I let it down, the hum is there. It's not having any effect though on this vertical distortion though. It definitely is affecting the audio. I'll try twisting it now. No, it's not having any real noticeable. I'm moving the transformer all over the place. It's not having any real discernible change on the image. Actually, yeah, it is. So I'm going up, down, up, down, up, down, up, down. Every time I do that, the image changes a little. There's one more thing to try. A number of you have suggested, hey, there's a filament transformer powering the tuner. Let's eliminate that. So there are 3 tubes, wired in parallel, run off 6.3 volts. I'm going to try powering them off battery. I meant to buy a lantern battery at the hardware store, but I forgot. So I'm going to try using a couple 3-volt lithium cells. It only has to work for a few minutes, so if this can pump out enough current, You know, if I need to, I've got a few more of these I could parallel some as well. So I'm going to disconnect the transformer and hook it up. It's pretty simple. Here it is on the schematic. So one side of the primary and one side of the secondary are both grounded. So we're going to disconnect that one wire on the primary and hook up the battery to ground and to point X. The tubes are glowing, so it's working for the moment. Got the set on how much juice those batteries have left in them. They're old, they're used. Come on.
No, that's still doing it.
It is still doing it, but doesn't it look better?
Yeah, it does.
Although I've been fooled before, and then after the set played, like warmed up, it got a little bit worse. I mean, there's definitely still some horizontal shimming, but it's the vertical that really bugs me. Yeah, I mean, it's still there. 22. These things are sensitive. Distorted just by touching the glass. So the horizontal shimmy is absolutely still there. I really do think the vertical's better though. No, it's still there a little bit too. And you stare at this test pattern for hours and you fool yourself pretty easily. Okay, back to the filament transformer, and I'll have to review the footage, but I think there is more distortion now. Certainly vertical, I think in both directions, but vertical, don't you think? The vertical looks more distorted now.
Yeah, it's better with
So I mean, it's squishing down. Yeah.
It was slower.
Was it slower?
It seemed slower.
Interesting. Yeah, I'm trying to decide, is that 60 hertz interference or is it 120 hertz? Now there's no half-wave rectifier in it. I mean, sorry, there are no full-wave rectifiers in this set. It's all half-wave. So there shouldn't be 120 hertz anywhere. It should all be 60 hertz. So you can see one traveling down here, but there's already another wave starting up here. So they're kind of, it seems like there's two at a time on the screen. And I heard that's indicative of 120 hertz interference. It's like, I think we have reached the point of diminishing returns. I've spent way more time on this than I ever intended to. Now, I also want to talk about the tube wiring, because that is another big difference between this and the Troubleshooting set. I did record a more in-depth explanation, but I think I might be better served by just quickly verbally explaining it. This tube is series strung, so a number of you mentioned, hey, why don't you twist the wires going between the tubes that carry the filament? Because there aren't any. You have tube socket, wire, tube socket, wire. They're wired, which is one wire going from tube socket to tube socket. A number of them have a filter choke between the tube sockets. And there is the occasional 1500 picofarad from the filament winding to the chassis ground to remove RF noise. That's what basically the chokes and the caps are there to do, is to remove RF. But that's not the puzzling thing. The puzzling thing is there are two strings, because if you wired all of these tubes in series, it's far more than 117 volts. On the other hand, if you split it into two strings, it's not enough to get 117 volts in each string. One of the strings, if you add up all the tube filament drops, all the 6.3 volt tubes and the 12.6 and so on, you get 75.4, which coincidentally is the same value as one of the strings in a very common Motorola 7-inch sets. For that, they added a big power resistor on the chassis, this guy up here. It's a big old 20 watt, I think, chassis mount, 150 ohm dropper resistor. Now here's the weird thing. So that would be the string on the left, where there's a 150 ohm resistor and then a 25 Z6 and a bunch of 6-volt tubes. There are the chokes and the filter caps. Oh, I misspoke. They're 5,000 picofarad, not 1,500. Then there's a string on the right, which has all the deflection tubes, high voltage oscillator, and the audio output tube. Basically all the 12-volt tubes and one of the 25-volt tubes. If you add all of those up, you get 119, which is slightly more than 117 this was designed around. So why did they add a 50 ohm resistor? Which is this right here, which is 200 ohms tacked together, and then it's just flopping around, and it's by the deflection circuits. When I measured the individual filament drop voltage across each tube, I was only getting 10 volts AC on these 12-volt tubes. I got about 20 volts on the 25-volt 25L6 audio output tube. They are running one of the strings lean by about 10%, 20%. I'm not sure why, other than there were issues and they were trying to fix it, and they thought maybe they experimentally determined that if they ran this string lean, maybe it was to reduce the hum in the audio, maybe it was to help reduce the horizontal jitters. I don't know, but this really doesn't need to be here. Theoretically, this set should run better without it. Because the other thing is, these two strings each have 300 milliamps going through them. There are two tubes that need 600 milliamps down at the bottom. That's why they join these up together and it flows through these two. So they're actually starving these two tubes a little bit. Now I already did try shorting out that resistor and it didn't make a huge difference. But boy, it'd be nice to not even have it there at all if you don't really need it. Before I do anything with that transformer, I want to play around with the TV A92 a bit. I verified its operation in a separate video. What I'm trying to do right now is take the composite video out and drive the video amp with it. Interesting. Well, this has a neat feature where the output level has 0 in the middle of the knob and you go positive and negative. I'm pretty sure I need to go the other way. And here I'm playing around with going positive and negative. Alright, so the TVA is working perfectly. And what do we see? We still have ripple. And now we can do something really neat. So we've got a nice clean signal. And notice that the tuner has no effect on it. That's because we're bypassing the tuner and the IF. So we can disconnect power to the tuner and see if that distortion all goes away. All I gotta do is cut the primary juice to that little transformer. So now we can do something we've never done before, which is to get an image on the screen without any power in the tuner. No AC, no DC. Those tubes are just off. There is some distortion, but I think we can all agree it's considerably less. It's just the same as it was when I had the tuner running off the battery, I would say. There's a little bit of a vertical thing moving like before, where the squares are getting a little bit taller as it moves across. But it's pretty darn insignificant. Likewise, I think there's a little bit of a snaking going through. Now, can you imagine if I had this TVA92 from the very start of this project, how much sooner we could have gotten to the heart of the matter. Alright, so next up, I am kind of curious about something. It definitely looks better when I use the TVA92 and inject a signal directly into the video amp grid, better than it did when I ran the tuner just off a battery. So I think there is still some AC leaking in, like, at the output of the detector, and that's having some impact. But what we're going to do next, I'm going to take out these extra filter caps I tacked in. I'm going to reinstall the filter choke, and we're going to remove the filament transformer. What you got there, Jupes? You having a little snack on a power cord? Sorry, buddy, but we need that. Because we are going to use that to power the filament transformer. We're going to unmount it and get it some distance away and power it up. First experiment, left everything the same, removed the transformer, still have the filter choke out, and we're running the tuner from 6 volts DC as provided by the TVA62. And it looks alright, but there is some 60 Hz distortion. More in the horizontal than in the vertical. So that's what I wanted to determine. It's not entirely the fault of this guy. It's gone. It's not in there. It's also getting through elsewhere. Now we know that when we injected video directly into the video amp that it looked even better than this, and we're going to repeat that in a moment just to make sure. Alright, I did nothing other than move the banana clips from the DC supply down to the video out, and I moved the red clip over to the capacitor that feeds the grid of the video amp. Now there is no juice going to the tuner at all. And that is absolutely more stable. No question about that. So, there are other issues other than these two hunks of iron. That's annoying. And it's what I've suspected for a while now, given how much troubleshooting I've done on this. It's not one thing. So I mentioned before, when I would try certain things, it would help a little bit. This would help a little bit. That would help a little bit. I am really leaning towards this just being a flawed design in a number of ways. So I don't think I'm going to be solving it. There is no quick fix. It's just not one thing. There's definitely some AC radiating outwards from that. We're still going to hook up. I got some wire here. We're still going to hook it up and move it around because I'm curious to see. So it looks better with that out. Is it just the fact that the tuner is running on AC, or is it the proximity of that? That'll be interesting to see. Now you may be wondering, hey, if it looks so great when you inject the video directly into the video amp, why don't you do that all the time with all your sets? I could, and some people do with sets. Yeah, you can get a fantastic picture because you just turned your TV into a monitor and you bypassed half of the set. Why don't I? Authenticity, the challenge of it. I want them to work as they did originally with the rabbit ears and static and their quirks and all that good stuff. Because I'm not sitting and watching this all day long. If I want to do that, I'll just get a flat screen TV or something if I want to have no interference or distortion. I want them to work as they were originally designed. And that's the trouble with this one, is I don't know how it worked when it was originally designed and produced. But it is cool to see. Like, wow, yeah, that's a rock solid, perfect image. So we know that the issue is isolated to this stuff. Finally, time to experiment. We are using the filament transformer again, but it's unmounted. We have long wires going to it. I also installed a new vertical output 12SN7, so we have full height now. And we do have waviness. So let's move this transformer around, shall we, and see what effect it has. First off, let's put it where it normally would be on the chassis. And about there. Try to get a good look at things. You know, I do have that vertical distortion going now. Move this very far away. And yeah, it does appear the vertical distortion is gone. Move it closer again. Let's just put it right. Oh yeah. I don't think there's any question now if we put this sucker right on the CRT. So clearly the shielding on this transformer is not sufficient. So, filament transformer right on the CRT. I'm moving it around, I'm rotating it, and so the orientation of it definitely makes a difference. So I'm holding it in the same space, I'm just twisting it. I can do it now. If I do it up front, it doesn't matter. It's on the side, or on the top. I mean, it's around the funnel, I guess you could say, where it makes a difference. Try not to break the CRT while I'm doing this. I'll back up a little so you can see what I'm actually doing. I'm doing this. Just holding it near it and twisting it. So the orientation it was in is like this. I wonder if we rotate it at 90 degrees, does it help? Well, I think it does. And if you recall in those Admiral sets, the latter editions, they went 45 degrees on their power transformer. So let's see, there it's 90 degrees from its normal position. Here's the normal position. We get that vertical stretching. You gotta look close, it's subtle, but it's there. Now let's go 90. The horizontal might be worse though, but I think the vertical distortion is... Well, let's go 45 now. Yeah, there is some vertical distortion. And back to the normal position. Yep, vertical distortion, and now 90 degrees. I'm thinking if I mount this 90 degrees from its normal position, I was going to set it down. Yeah, the vertical distortion is definitely diminished considerably. Obviously we do have some horizontal wavering, But we did that, we had that when we were powering the tuner off of DC as well. So I think that's a separate issue of the AC leaking into the sync pulse. Now the mounting holes don't line up to do this at 90 degrees. I could attach just one of the mounting screws, I suppose. And let's see if I just physically move it further away, it should help too. Yeah. Well, let's see, can I put this somewhere so we can get distortion and then I can cover it with that mu metal and we can see if the shield is effective. If I put it upside down, maybe. Alright, we have vertical distortion. I can't really get the shield down over it though. Nuts. I guess one thing we could try, if I can hold this near it so we can see that there's distortion. All right, lots of distortion. And let's put it down inside this. No, it's down about here inside the shield. You can see where I'm pointing. It's right about here inside the shield. Wow, looks like the horizontal distortion is less. I mean, yeah, the shield works. The shield works. So if I could cut this shield up somehow or get a smaller version of it and put it over the transformer, I think that would be very effective too. And out of the shield. Interesting that the horizontals seem to get better inside that shield as well. Well, I guess it's about the same as when I put the transformer away. Alright, so I guess I have a few choices. Shield the transformer, rotate it 90 degrees, physically move it some distance away, or mount it somewhere else on the chassis. I mean, there is one thought. So there are a couple holes over here that look like they actually might be the right spacing or pretty close to it. It's the alternate location for the speaker. I could try mounting it over here. I took a photo of the grid while I had the tuner running off batteries, and I posted it under the community tab on my channel. And I mentioned that there would be some revelations in this installment, and I wanted to go over what those revelations are. Basically regrouping what we know about this set. We know it was an obscure manufacturer. Few of these are made, even fewer still exist. We are pretty certain that this set saw some servicing shortly after it was made. For some reason they moved the speaker over. It appears they replaced the tuner. It appears they replaced the high voltage caps. We also know that one of the tubes in the tuner, as it came, which was a mirror tone branded tuner, which is a part of Meck, or was, does not match the tube chart. It had a 6AU6, where the tube chart says there should be a 6AG5, and a 6AG5 is more commonly found in a tuner. I've tried using both. You can tune in a signal with both. I'm having a hard time determining exactly which works better. Earlier I thought the 6AG5 was the clear choice. I've tweaked around with the tuner and the tuning slugs a bit more. Now I'm not so sure. So that does not help matters any. Another revelation was about them running one of the filament strings about 10% lean. Again, were all these things attempt to solve issues with this chassis? Is what I'm getting at. And finally, the closest thing I know of to this, that there are many examples of, is the TV149 by Teletone, but it has some significant differences. One, they do not run the filament string 10% lean, and they do not power the tuner from a transformer. It's series strung with the rest of the tubes. And there are a few other differences, like they derive the screen voltage for the video amp tube from a different source. It's divided down from B++ with an extra filter cap on it. Did they know something? Did they take the Meck design and work out the kinks? I don't know. I don't think I ever will know. What all of that gets me to is maybe it's time I wrap this up, because these problems might be inherent in the design and there is no solution other than to start redesigning things.